Welcome back. Thank you for clicking on today's video. Today we're going to be talking about how to summarize paired data. So if you remember when we were looking at this before, we talked about how you would have a pair of measurements on one individual. Now the thing that happens is you'll end up calculating these differences and then you'll just have one quantitative measurement, just like we had in previous chapters where we're analyzing one quantitative variable. So that means also that the notation is very similar. So we have sample mean, we have sample standard deviation, we have sample size, and we have then the population mean. So for one quantitative variable, if you remember, the notation for these items was x bar, s sub d, n, and then mu. Oh, Becky, I tricked you. This is one quantitative mean, one quantitative variable. This is paired differences. Silly billies. So x bar, s, n, mu. Now here, the paired differences, which go with these items, are going to have the subscript d. Here, when they don't have paired values and it's just one quantitative variable, we have x bar, s, n, and mu. Technically, you could add an n sub d to get the number of pairs, but this is the notation. It's the same as we've had in the past. It's just now to denote that they're differences, we add the subscript d. So what we're going to be doing is we're going to be finding those differences by taking one measurement and subtracting a second measurement from it. So this is the difference, this is the first measurement, second measurement. The most important thing is that you remember the order and you calculate it the same the whole time. So I have an example of this. We talked about this when we were looking at options for dependent data. So I talked about how the way you spend your time would be dependent because you would expect that the computer time would affect TV time and vice versa. So what I have here is students. So there's 25 students, and then they each have a pair of measurements. So this is paired data. It's not repeated measurements because it's not taken over time. It's a paired group of measurements for each of these individual students. So the way that the differences are calculated is computer minus TV. So 30 minus 2, this student had a difference of 28 for their computer versus TV time. 20 minus 1.5, their difference is 18.5. Now here for student 3, you notice that it's 10 minus 14, so we have negative 4. So in this situation, when it's negative, that means TV time is greater. If it's positive, it means computer time is greater. So down here, when we get to student 18, you see that their difference is 0, which means there's no difference between their computer time and their TV time. So if we were to continue on calculating these differences, we would have 21 minus 35, and that gives me a difference of negative 14. Then we have 2 minus 1, so a difference of 1, 9 minus 4, a difference of 5, 14 minus 0, a difference of 14, 21 minus 14, a difference of 7. Now in the end, we're only interested in this column, which is essentially the xd. Now here, this would be x1 and this is x2. So remember that that formula is just to calculate the differences. You take some measurement minus a second measurement. That's what this would represent here. These are the differences. This is the first measurement and the second measurement. And we always keep the same order because it helps us to know then which measurement is greater. Now, when you actually find the mean for these, and I'll show you that I've already given it to you. It's the sample mean up here of 5.36 and a standard deviation of 15.24. When you find it, you use the same method you do for finding means and standard deviations in your calculator. So I'm going to clear out my lists, and then in list 1, I'm just going to enter the differences because the method for calculating a mean is the same if it's a difference or if it's just one quantitative variable. So what you'll see me doing here is entering all of the differences in this column as they're stated. So that would include negatives and positives. So remember, we care about that direction. It impacts the way that we make our interpretation. So we'll do it exactly as it's stated. Okay, so we have 25. I have this to verify my answers, so I'm not going to check it, but you always should check your work if you don't have anything to verify it by, and I did something wrong. Okay. Okay, there it matches. Now, this says X bar and S and N because it doesn't know it's in the context of differences, but it's the exact same thing. Which the beautiful part about this is then when we're doing the analysis for this, like when we did a hypothesis, or excuse me, a confidence interval for mu, it's going to have the same formula because it's really the same mathematical calculations. It's just in the context of differences. The other thing that you'll notice too is that this is going to just be a box plot for these differences. So the same way that we reviewed conditions for one quantitative variable, we'll do it here as well. And we're looking for symmetry. And again, we're just going to be analyzing that group of data. So in future videos, we'll start using these measurements, but now you know how they're calculated and where they come from. See you in future videos.